choosing to take OCI Data Science Professional course and get certified. My name is Hemant Gahankari. I am a Senior Principal Training Lead at Oracle University. As a data scientist or a machine learning engineer, it is our day-to-day job to get data, to prepare data, to build and train models, evaluate models, deploy and scale models, and also automate machine learning pipelines. With OCI data science service and AI services, we can do all these tasks efficiently. Through a series of expert tip videos, we'll show how to use some of the powerful, at the same time simple to use features of the OCI data science service and AI services. Hope you will find those videos useful. Thanks for listening.
This is Module 1 covering Introduction and Configuration. This first lesson is the Introduction to the Oracle Cloud Infrastructure Data Science Cloud Service. I'm Wes Pritchard, Senior Principal Product Manager for Data Science and AI Services. Before we get into data science at Oracle, let's take a fun look back at history and how we got here. In the 1300s, William Ockham, a philosopher and friar, believed that scientists should prefer simpler theories over more complex ones. The principle that bears his name, known as Occam's razor, can be applied to machine learning by looking for the simplest solution. In the mid-1700s, astronomer Tobias Meyer made a quantitative argument that more data is better. He was studying the motions of the moon and collected 9 times as many data points as necessary, claiming that this made his observations more accurate. Because of this, he's often considered the first true data scientist. In 1952, Arthur Samuel, an IBM pioneer in computing, gaming, and AI, coined the term machine learning. He designed a game for playing checkers and discovered that the more the computer played the game, the more it learned winning strategies from experience. In 1962, mathematician John W. Tukey predicted the effect of modern-day electronic computing on data analysis as an empirical science. However, Tukey's predictions occurred decades before the explosion of big data and the ability to perform complex and large-scale analyses. In 1997, an IBM supercomputer called Deep Blue defeated chess grandmaster Garry Kasparov in only 19 moves. Kasparov resigned after this match. The highly advanced supercomputer could calculate as many as 100 billion to 200 billion positions in the 3 minutes traditionally allotted to a player per move in standard chess. In 2008, Dr. DJ Patil of LinkedIn and Jeff Hammerbacher of Facebook coined the term data science to describe an emerging field of study that focused on teasing out the hidden value in collected data from retail and business sectors. Given that historical background, let's take a look at how data science is being applied today. In 2021, in the midst of the global COVID-19 pandemic, professor and psychologist Anthony Klotz coined the term the Great Resignation to describe a new trend of employment dissatisfaction and turnover. Many businesses want to track, analyze, and predict the patterns in their employee retention. In this course, we will use employee attrition as a use case to connect our machine learning activities to a real-world business problem. Better yet, we will help you build a predictive ML model yourself in the independent student lab that accompanies this course. Now it's time to dive in and discuss Oracle's approach to data science and AI. It's really all about data. For many years, the data available to organizations was the structured data in their business applications. And this is still very important business data, but it's certainly not the only data. Organizations have many types of unique and often unstructured data from many different sources. Things like equipment sensors, mobile apps, social media, custom interactions via voice and text, videos, images, documents, and many more. Organizations want to use all data to produce new insights and new data products. They want to improve their business operations by creating better customer experiences and anticipating service demand and preventing avoidable equipment outages. The next generation of business problems, or scenarios if you will, means being able to use all data. And we need the capabilities provided by data science, machine learning, and AI to understand and use that data. Oracle AI is this portfolio of cloud services for helping organizations take advantage of all data for the next generation of scenarios. Notice the foundation of all of this is data. That's that bar at the bottom. Obviously, AI and machine learning work on data and require data. Now, the top layer of this diagram is applications, and this loosely refers to all the way AI is consumed. That could be an application, a business process, or an analytics system. Between the application and data layers, you see two groups here. The AI services on top and the machine learning services on the bottom. The difference between the two groups is that machine learning services are used primarily by data scientists to build, train, deploy, and manage machine learning models. Data scientists can work with familiar open source frameworks in OCI data science. And by the way, that's the cloud service, that's the focus of this course. Data scientists and database specialists can take advantage of machine learning algorithms built into Oracle Database. And an important service that supports both machine learning and AI services is OCI data labeling. Because when you're building machine learning models that work on images, text, or speech, you need labeled data that can be used to train the models. AI services contain pre-built machine learning models for specific uses. Some of the AI services are pre-trained, and some are trained by the customer with their own data. All are used by simply calling the API for the service, passing in data to be processed, and the service returns a result. There's no infrastructure to manage. And even though we'll be focusing primarily on OCI data science in this course, we also have some lessons on the AI services and on data labeling. There's already a separate course that covers machine learning in Oracle Database. Now, those AI and ML services I just showed you don't stand alone. They're supported by many other services available in Oracle Cloud Infrastructure, including business analytics and graph analytics and many forms of data integration and data management, all running on the basic cloud infrastructure. These services can be combined in various architectures to support many different scenarios. We've defined Oracle AI and the services it comprises. Now let's take a closer look at Oracle Cloud Infrastructure Data Science. I'm just going to abbreviate it as OCI Data Science. OCI Data Science is the cloud service focused on serving the data scientist throughout the full machine learning lifecycle with support for Python and open source. As you can see by the icons in this graphic, the service has many features that we will cover throughout this course. Now let's look at the three core principles that guide the product. The first principle is about accelerating the work of the individual data scientist. Data scientists coming out of universities today have been trained using open source, and that's what they're most comfortable with. But using open source tools on a laptop means managing lots of libraries from different sources and being limited to the compute power on the laptop. OCI Data Science provides data scientists with open source libraries along with easy access to a range of compute power without having to manage any infrastructure. It also includes Oracle's own library to help streamline many aspects of the data scientist's work. Now, the second principle is collaboration. It goes beyond individual data scientist productivity to enable data science teams to work together. This is done through the sharing of assets, reducing duplicative work, and supporting reproducibility and auditability of models for collaboration and risk management. And the third principle is about being enterprise grade. That means it's integrated with all the OCI security and access protocols. The underlying infrastructure is fully managed. The customer doesn't have to think about provisioning compute and storage, and the service handles all the maintenance, patching, and upgrades so users can focus on solving business problems with data science. Let's drill down a bit more into the specifics of OCI data science. First of all, it's a cloud service to rapidly build, train, deploy, and manage machine learning models. It serves data scientists and data science teams throughout the full machine learning lifecycle with support for Python and open source. Users work in a familiar Jupyter Lab notebook interface where they write Python code. And users preserve their models in the model catalog and deploy their models to managed infrastructure. Let's cover some important product terminology that we will use throughout the course. Take some time to digest these terms and concepts. Projects are containers that enable data science teams to organize their work. They represent collaborative workspaces for organizing and documenting data science assets such as notebook sessions and models. Note that a tendency can have as many projects as needed without limits. Notebook sessions are where data scientists work. Notebook sessions provide a Jupyter Lab environment with pre-installed open source libraries and the ability to add others. Notebook sessions are interactive coding environments for building and training models. Notebook sessions run in managed infrastructure, and the user can select CPUs or GPUs and the compute shape and the amount of storage without having to do any manual provisioning of environments. Conda is an open source environment and package management system that was created for Python programs. It's used in the data science service to quickly install, run, and update packages and their dependencies. Conda easily creates, saves, loads, and switches between environments on or in the notebook environment. Oracle's Accelerated Data Science, SDK, and we're going to call that ADS throughout this course, but the ADS SDK is a Python library that is included as part of OCI Data Science. ADS has many functions and objects that automate or simplify the steps in the data science workflow, including connecting to data, exploring and visualizing data, training a model with AutoML, evaluating models, and explaining models. In addition, ADS provides a simple interface, access the data science service model catalog and other OCI services, including object storage. Now, you already know what a model is. Models define a mathematical representation of your data and business. You create models in notebook sessions inside projects. The model catalog is the place to store, track, share, and manage those models. The model catalog is a centralized and managed repository of model artifacts. A stored model includes metadata about the provenance of the model, including get-related information, and the script or notebook used to push the model to the catalog. Models stored in the model catalog can be shared across members of a team, and they can be loaded back into a notebook session. Model deployments allow you to deploy models stored in the model catalog as HTTP endpoints on managed infrastructure. Deploying machine learning models as web applications serving predictions in real time is the most common way to operationalize models. HTTP endpoints are flexible and can serve requests for model predictions. Data science jobs enable you to define and run repeatable machine learning tasks on fully managed infrastructure. OCI Data Science provides multiple methods for access. The OCI console is the most common method. The OCI console provides an easy-to-use, browser-based interface that enables access to notebook sessions and all the features of the service. This will be the interface used throughout the course. The REST API provides access to service functionality but requires programming. An API reference is provided in the product documentation. OCI also provides programming language SDKs for Java, Python, TypeScript, JavaScript, .NET, Go, and Ruby. These SDKs enable the user to write code to manage data science resources. We'll provide some examples of how the Python SDK can be used to deploy models and create jobs. The command line interface provides both quick access and full functionality without the need for scripting. As a cloud service on OCI, OCI Data Science is available through regions. Regions are globally distributed data centers that provide secure, high-performance local environments. That makes OCI Data Science available around the globe in commercial, government, and dedicated regions. Oracle is frequently adding new regions, so visit oracle.com/cloud to get the latest information on cloud regions. In this lesson, we introduce OCI Data Science and some of its key features and terminology. The next lesson will cover provisioning and configuring the cloud environment to use OCI Data Science throughout the machine learning lifecycle.
Hello, and welcome to this module on the ADS Software Development Kit. My name is John Peach, and I'm a data scientist on the Oracle Cloud Infrastructure Data Science Service team. In this module, you will gain a high-level understanding of the ADS SDK, its goals and capabilities. The Accelerated Data Science SDK is designed by data scientists for data scientists. It covers the end-to-end machine learning lifecycle. The goals are to integrate OCI services in a way that fits the data scientist workflow. For example, it will integrate the Vault into the Autonomous Database and Big Data Service using a bunch of classes around the Secret Keeper class. This makes it very easy for data scientists to store their credentials and access these services securely. It also aims to improve common data science tasks such as exploratory data analysis with feature types and also performing hyperparameter optimization using the ADS tuner. In addition, the ADS library provides auto machine learning and machine learning explainability. There is two versions of ADS. There is a version that's publicly available that you can download from GitHub or install from PyPy. And then there is a special version that is installed in some conda packs within the Oracle Cloud Service that has the auto machine learning and machine learning explainability features. There are several different ways that you can access the SDK. As I mentioned before, it is installed in conda environments in the data science service and is readily available to you just by simply using the service. You can also install it using PyPy or from GitHub using the pip install command. What are some of the features of ADS? First, it connects to your data sources. You need access to your data no matter where it is. ADS provides connectors to many of the popular data source locations. Data visualization. You need to understand the nature of your data, and visualization is a key method for doing this. ADS has smart plotting that provides reasonable default plottings for different types of data. ADS also has feature types that allows you to plot your data in a reusable fashion based on the type of measurement that you're using. Understanding the relationships between features and different types of correlation plots is also provided. Feature type engineering. Often the difference between a good model and a great model is the feature type engineering. ADS can do an analysis of your data and provide recommendations for feature type engineering that you can perform. Model training. Use Oracle Labs Auto Machine Learning to train collections of models. Or for more control, you can use the ADS tuner to do hyperparameter tuning optimization. ADS has classes that quickly bundle your model up so that they can be deployed. Model evaluations. Understanding how well your model is performing is key. ADS provides classes that allow you to perform standard evaluations with a couple of lines of code. Model interpretability. Understanding what the model is learning and making sure it's learning the correct things is key to developing trust in your model. Also, being able to explain what the model is doing so that you can explain it to others is an important technique for building trust within the model. Model deployment. A common problem is getting the model into production. ADS makes this easy. It has classes for most common model types and also supports generic models. So no matter what type of model you have, in a couple of lines of code, you can deploy the model into production. Connecting to data sources. Data is stored all over the place and you need to be able to access it. Data is often too large to fit into your notebook session. You can use ADS to limit the data transfer over the wire. Local storage is a common location where you would store your data. This is the block storage within the notebook session. ADS provides easy access to that. For larger datasets or for sharing datasets, object storage is commonly used. ADS uses the FSPEC protocol to allow you to use Pandas to access object storage as if it was sitting on your local drive. This is done through the OCI protocol, and Pandas can files on object storage. A lot of our data sits in Oracle databases. ADS provides an easy connection to these databases. Tools such as the Oracle DB Secret Keeper allow you to store login credentials and the DB wallet file in an OCI vault, so that you don't have to expose this information into your notebook. The ADB Secret Keeper works with the Autonomous database. ADS provides integration to third-party cloud providers. With ADS installed, Pandas can connect to providers such as S3, Google Cloud Storage, Azure Data Lake Storage, Azure Blob Service, Dropbox, and many more. For non-relational data, ADS provides access through the Dataset Factory class to make easy connections to NoSQL databases, run queries, and return results. The OCI Big Data Service is a Hadoop-based service that has HDFS for its file storage system. ADS allows you to easily connect to BDS without having to copy the data to your local storage. ADS also provides access to the web using HTTP and HTTPS to read files that are on the World Wide Web directly into a data frame. Data visualization. Exploratory data analysis is critical to understanding your data. It can be time-consuming to create and throw away graphs only to create them again the next time you use similar data. The feature type classes provide the same defaults for visualizing your data. It is also very easy to create feature types that allow you to customize your visualization. You can then reuse these visualizations in different projects or across the organization. Further, feature type system provides summary statistics, summary visualizations of each features, and correlation heat maps. Feature type engineering can be a challenging problem. Feature engineering can greatly improve the quality of your model by taking existing features and generating new ones from it. This transforming the data that you have into other types of relationships that the model can learn from. ADS has built-in functionality to support this. There is a class called ADS Dataset that wraps a Pandas data frame. It provides transformation suggestions and can do it automatically as well. It supports categorical encoding, null values, and imputation. It can make recommendations on what changes you should make to your data to create better features. Model training. Once you have your data prepared, it is time to make a model. ADS can fully automate the process using auto machine learning technology. It can try many different types of model classes, tune the hyperparameters, and give performance metrics for each model. The ADS tuner performs hyperparameter tuning. After a model is trained, ADS can also package up your necessary files to create a model artifact, save that model artifact to the model catalog, and then you can push it to production. No longer do you need to struggle by productionalizing your model. Model evaluations. You have a model or many models. You need to understand the performance and compare them. ADS Evaluator allows you to perform comparisons of different models. It offers things such as common tools, metrics, and charts. It understands binary and multinomial classification and regression. It outputs metrics and charts that are appropriate for the type of problem that you are working on. No longer do you need to regenerate these types of charts over and over again and make sure that you have the correct evaluation charts and metrics. ADS just does this for you automatically. Model interpretability and machine learning explainability. You can develop trust in your model if you can explain what it has learned and what it's doing. By interpreting the model behavior is key to understanding what it is doing and what improvements can be made in future models. ADS provides tools to interpret models that are agnostic to the model class itself, meaning that the tools are not dependent upon the type of model that you built. It provides explanations through the ADS module that are interpretable, model agnostic, and provides tools that allow you to do what-if scenario testings. That is, you can change input values and see how the model behaves. In addition, it can provide local explainability. This means that you can take a black box model and understand why a model made a prediction that it did on a specific observation. It also provides global explainability, where you can understand what the model learned and how it's behaving. It does this through using partial dependence plots and ALE plots, accumulated local effects plots, to understand the general behavior. Use this to see if the model is learning what you want it to learn and understand the relationships between the data. Model deployment. Many data scientists face a huge challenge when it comes to productionalizing their models. They have it running in their notebook session, but how do they make it available to be used at scale in a secure method? ADS provides the ADS model framework, which is a set of classes that allows you to deploy models of different types. With a few simple commands, you can have a model into production. ADS supports collections of models such as Oracle Labs Auto Machine Learning, PyTorch, scikit-learn, TensorFlow, and many more. It also has the ability to support generic models. No matter what your model type is, it can be supported and deployed with a few simple commands. When your model is in production, you need to understand what is happening. It integrates with OCI logging service and creates a prediction and an access logs. These allow you to understand how the model is being accessed and also what the prediction results are from the model. Let's wrap up. In this module, you have learned the goals of the SDK are threefold. You've learned how to access and install the library. You've learned some of the ways that you can connect to different types of data, how to visualize your exploratory data analysis quickly and simply, the fact that ADS provides guidance through feature engineering, different tools that ADS has to help you train and optimize your models. You've also learned how to perform model evaluations to better explain and understand the quality of your model. We also discussed model interpretation and tools that allow you to push your model into production. Thank you very much.